What you might notice on this next page is, again, we have another type of problem 2. Pretty much, guys, I found 2 different questions. What I want you to do is, if you think you're going to need some extra help, why don't you do these and I'll give you the answers. The answer to this problem 2 is 1, 4, and the answer to this got it is 3, 4, so a little bit easier. So if you guys think that, wow, Mrs. L, I need to get some of this, I need to do some more practice with this, these were very ugly, which is why I chose them as in the video. If you have questions getting these answers, come in tomorrow, ask them in class so we can go over anything that you might need. Moving on, though, to problem 3. Again, if you need extra support, do these problems, see if you can get these answers, and then come in and ask if need be. Problem 3. A snack bar sells 2 sizes of snack packs. A large snack pack is 5, a small snack pack is 3. In one day, the snack bar sold 60 snack packs for a total of 220. How many small snack packs did the snack bar sell? Wow, ooh, that was a tongue twister. So pretty much we're selling 2 types of things. We have a large one and we have a small one. We have to make sure that we label what we want. Since it comes first, why don't we go ahead and just make, X the, where is it at? We'll make X the large, okay? And we'll make Y the small. So just label your problem, X is large, Y is small. Now something I notice is that they give us totals. We've got to make our equations, guys. And this is what I noticed today in classes. This is where some of you are struggling, okay? Now let's start at this sentence. Here's some information for us, but it doesn't have like an equals or a total. I see that I have a total sold, and the total sold is 60. Hopefully you agree with me. I also see that I have a total money or a profit that was made, and I see that that number is 220. I hope that you agree with that as you read through. Now in math class, we take our English information and we translate it into math information. If we know that we sold a total of 60 items, that is X, which is the large, and Y, which is the small. And we already have an equation made. Now let's be very careful with this 220. 220 is the quote-unquote money equation. Now if we know that every large is 5, that's how we write it. And we know that every small is $3, that's how we write it. Check out those equations, pause the video, try to make some sense out of that. If you have questions, we'll come back and practice some extra stuff. Now notice we have 1, 2 equations. Which equation do you think is easier? Hopefully you picked equation number 1 is easier. Let's practice solving this problem using substitution. So I'm going to rewrite equation number 1. I'm going to have to write it kind of small here, okay? And pick a letter, guys. I could care less which one you solve for. Why don't we just solve this problem for the letter X? So I'm going to solve it for the letter X. So I'm going to take away Y from both sides. I get 60 minus Y equals X. Now notice X is now by itself. So you can give it a little smiley face, and even better, you can put that box because we are now ready for substitution. If we are ready for substitution, remember that we kind of manipulated equation number 1. So if we manipulate equation number 1, that means we plug it into equation number 2. Sorry, we had a little break there. Okay, so we just manipulated equation number 1, which means we put it into equation number 2, and we're going to substitute it in for X. So you see this X right here? It's going to disappear. So we get 220 equals 5 times what we just got in the box. So we just got 60 minus Y. And then we have the plus 3Y in the back. Now what we have to do, guys, is solve this, and you're very capable of doing so. 5 times 60 is 300 minus 5Y. Remember, we used that word that starts with a D and sounds like distribute. So we get positive 220 equals positive 300 minus 2y when we combine our like terms. Take over the 300, so you get negative 80. Be very careful with your positives and negatives, all right? Negative 280 negative 80 equals negative 2y. Divide by negative 2, and you will get 40 equals y. Once you get one answer, I like to use the box where we were to help us plug into the other. So remember where we had that box way over here? We had 60 minus y equals x. So let's plug in y. 60 minus 4 equals x. Well, 60 minus 4 is 56. That equals x. And now we have... No, it's not 60 minus 4. I just looked at my answer key. Well, that was cute. It's 60 minus 40 equals x. And 60 minus 40 is 20. Now, since it's a word problem, we will label. We will say there were 20 x, so that's 20 large that were sold, and 40 small. And there is our answer for our word problem. Moving on, we have another fun-filled word problem. I know we all love word problems. And I'm going to get it set up, but give me a minute. Moving on to the second part, we have another word problem. You pay $22 to rent 6 video games. The store charges $4 for new games and $2 for older games. How many new games did you rent? The first thing to recognize is that, again, we have those ideas that we got to have an X and a Y, okay? So the two items that we're taking home are new games, X, and old games, Y. You can switch those up. It really doesn't matter as long as you get, as long as you get X and Y and you stay consistent, okay? So we do know that we have a total, again, just like we did in the last problem, of 6 video games. We also know that we have a total, in this problem, we have a total money of $22, a total value when we checked out. Now the 6 games are comprised of the X and the Y. They are comprised of the new and the old. The 22 is comprised of 4 for every X that we got, and $2 for every Y that we got. Notice now we have 2 equations, 2 variables. I do hope that you notice the top equation is a little easier because it has single variables that have coefficients of 1. So what that means is when it kind of comes to my problem, that's the equation I'm going to focus on. If we call it equation number 1 versus equation number 2. Equation number 1, let's go ahead, rewrite it, and then let's set it equal to one of the variables. Guys, I don't care which variable you pick as long as you solve for one of them. Why don't we move the X over to the other side, and we are therefore going to be solving for Y. Well, 6 minus X turns into 6 minus X, and that equals Y. You can put this in the box, and then you'll be able to substitute it in the next step. Since we manipulated equation number 1, we need to plug it into equation number 2. So if I rewrite equation number 2, I get 22 equals 4x plus 2. Now remember how we solved for y? Remember how we solved for y right here in this box? See this y up here next to the 2? It's going to get subbed in with 6 minus x. That was the whole point of what we just did. Now we solve it like a basic equation. 22 equals 4x plus 12 minus 2x. I use that word that sounds like distribute. Very good. And then I get 22 equals 2x plus 12 when I combine my like terms. I am running out of room, so I'm going to draw an arrow so I don't get too lost. And I need to minus 12 from both sides. When you minus 12 from both sides, you get 10 equals 2x. And when you divide by 2, you get 5 equals x. Remember, please, that 5 equals x means that that is the number of new games. Now that is really all the problem wanted, but you may as well, if you wanted to, you could plug it in and figure out how many old games, right? Since you know in this box over here, in the green box, if you want to draw another arrow, you knew in the green box that 6 minus x equals y. So you could even do 6 minus 5 equals y, and you could figure out how many older games they got that night, okay? Or you got, I guess. And if you wanted to check that, you most certainly could. Since the new games, it says, are $4, 5 times 4, see my fingers, 5 times 4 would be 20. And since the old games are $2, 1 times 2 is 2, well, 20 plus 2 is that $22 that you were going to spend. Now, just like we did yesterday, moving on, just like we did yesterday, we can get special cases, okay? So we're going to focus on our special cases, such as pretend you get 2 equals 2. Let me ask you, when does 2 equal 2? I hope you're thinking to yourself, well, Mrs. L, 2 equals 2 is all the time. But if you get a statement like 8 equals 2, then you're going to say, Mrs. L, 8 never equals 2. Well, if you get 2 equals 2 at the end, in other words, your x's are going to cancel out. Can we say that? X's or y's cancel out when you do the math. If the x's or the y's cancel out and you get 2 equals 2, that's going to be an infinite solution. If your x's or your y's cancel out and you get 8 equals 2, that's going to be a no solution. You just need to be very careful that you're following the correct order, because if you don't follow the correct order up here, remember how I told you we manipulated the first equation and we plugged it into the second equation? If you accidentally manipulate the first equation and then plug it into the first equation, you're going to think it's infinite solutions. So be very careful that if you manipulate one equation, you plug it into the other equation. But let's look at some special cases. Ooh, I like letter A. I'm hoping you guys see right away that letter A is a really nice problem because it is ready for the box. Because X is isolated. We like that. So in the second equation, since we're kind of using the first equation for the box, the second equation, we rewrite it, but we put in the negative 2y plus the 4 in place of the x. Remember, substitution. Plus 7y equals 14. Now let's distribute through. 3.5 times 2 is negative 7y. 3.5 times 4 is 14, so plus 14 equals, I forgot my plus 7y, didn't I? I got to drag it down. Equals 14. I was getting ahead of myself. Notice, guys, that the 7y's cancel each other out, and you end up getting 14 equals 14. Now, what does that mean to you? Well, you tell me. Does 14 equal 14? Yes. I know you're thinking to yourself, yes. So what does that imply? That implies if you were to graph this thing, you would have infinitely many solutions. Because if you graph them, they would be the same line. That might be something worth noting. If graphed, they would be the same line. That way you can compare today's lesson for infinitely many to yesterday's lesson for infinitely many. Oh, I know it's exciting. Let's move on and see what else is coming. We got another special case to look at, and I'm hoping what you see is that the first equation is ready for the box, equation 1, and it can get plugged in for y, boom, 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 for the second equation. So let's rewrite the second equation. Instead of y, 3x minus 11, and then continue with the rest of the problem. And that came from the second equation. Notice again how the 3x's cancel each other out when you go to solve, and you get negative 11 equals negative 13. Now, tell me how true that is, guys. Does negative 11 equal negative 13? No way, right? That means there are no solutions, because negative 11 is not negative 13. Now, what would this look like if you graphed it from yesterday? I hope you remember, these would be parallel lines from yesterday. Parallel lines are lines that have no solution, just like this particular problem did. Moving on to the next problem, we have the got it, and it will again be another special problem. But if we notice this particular problem, it has stepped it up a level, and the reason it stepped it up a level is because neither x nor y are by themselves, okay? So we're going to have to kind of play around and be good with our fractions. I know. What I'm going to do is isolate. It's kind of difficult to pick on this problem. They're pretty ugly. Why don't we isolate x in the top equation? That's going to be our guess. ISO stands for isolate. You ready? Now we're going to need to take our time with this, okay? Equation 1, 6y plus 5x equals 8. Let's try to isolate this x. Well, take over the 6y to make it negative. I think you all are capable of that. Now what we get the privilege of doing is dividing everything by a 5. Yay! So we get x equals negative 6 over 5y plus 8 over 5. Now, we do have an equation that is set equal to x, but it is not pretty. And I agree with you, that's ugly, and we're going to have to plug that in equation number 2, so be patient. So instead of x in equation number 2, we're going to have 2.5 times that quantity up there that you see, the quantity we just got. And that replaces x, and then we still have the 3y, and we still have the equals 4. Now you guys have to be pretty good at distributing here. Okay, you're going to distribute and multiply through. Now I grabbed my calculator because there's a little bit of a shortcut on these things, but if you don't have this, you better learn how to figure it out, okay? And I'd be more than happy to help you. 2.5 times negative 6 over 5, watch this, is negative 3. How nice is that? And then it has a y. 2.5 times 8 over 5 is a positive 4. Well, that wasn't too bad, was it, guys? The numbers actually turned out to be pretty whenever we worked it out. Notice the y's cancel each other out, and we get 4 equals 4. Does 4 equal 4, everybody? Hopefully, I hope, right? You guys will say yes to me on that. That means in this particular problem, there are infinitely many solutions that we could come up with where x and y are the same for both equations. If we graphed it, they would be the same line. On the back, we have 2 more problems. And these problems, again, are just kind of special case problems. I'm going to go through them quickly. If you'd like to pause the video, you can certainly do that and try them on your own and just kind of fast forward to see the answers. That might be something really good for you to try on your own. All right, here I go, part A. I can put a box, and are these just exactly the same? Let me look. Nope, they're a little bit different. It looks like I tricked you up just a little bit on this one. It looks similar, but it is different. Alright, so let's have some fun. I know that's what you're thinking this is, right? Fun? We're going to take that box, and we're going to put it in for x. So we get 2 times negative 2y plus 4 plus 4y equals 8. Distribute in. Negative 4y. When we distribute, plus 8 plus 4y equals 8. I distributed in my 2 from the outside. You get 8 equals 8. And I hope you remember that that's infinitely many solutions. And one more, okay? Again, you can always pause the video, check this out, try to solve it yourself. Is this one might be the exact same as the one we just did. 3x minus 11. This one's the same as the last part B, so I'm not going to do this one because, well, we've already done it. So the main idea, guys, is that you have to follow your steps, okay? Important things to remember. Number 1, you need to isolate one of the variables in one of the equations. That's extremely important. Like, that's the whole point of substitution. Number 2, you need to take that answer and then you need to plug that answer into the other equation. And I want you to capitalize the other equation because that is incredibly important. Step 3, you will be ready to solve it like a normal algebra problem then. And then step 4, after you solve, you take that. Boy, that's messy. There we go. You take that and solve for the other variable. And you can use, and this step variable, at this step, when you take it and you solve for the other variable, you can use any equation you want, but I find it easiest to put it in from, I'm going to say easiest to substitute back into the isolated variable equation. Isolated variable equation. And if you go back through, you'll see what I mean. If you have any questions, make sure you start them or highlighted them so we can go back through and answer them tomorrow in class.